machine learning regression project. So this regression is an important topic or task, and so the project we are going to see in this session is going to be predicting the sales of products for a FMCG company. Okay, so it means like we are going to predict the sale value. Okay, so that part I hope it will be clear. Predicting the sale means sale is actually something based on amount, right? So money based. So how much sale has happened, and that is going to be a continuous value. It's not like yes or no or this or that, something like that. Okay, so apart from that, we have some rest of things called as predicting the sales of products from a FMCG company. So what is this FMCG company? So let us move to the introduction of this project. Let us understand what all we have, and then we'll start working towards it. So talking about the introduction, a large Indian retail chain, okay, like for example, you could consider something like Mart, like a lot of marts are available, right? So Reliance and all, they used to have their stores in different places of India. So like that, there is a large Indian retail chain has stores across 3 states, particularly in Maharashtra, Telangana and Kerala. And these stores stock products across various categories such as FMCG, which is fast moving consumer goods. So that's what a FMCG is, fast moving consumer goods, eatables, perishable ones and others. So these are set of products like a fast moving consumer goods. So we are going to predict the sale of these things. So why we are actually implementing here is they are trying to manage the inventory is crucial for the revenue stream of the retail chain, because for example, in the next month, if they can predict this much sale can happen, so they could like for example, they could be prepared for it. So meeting the demand is also an important task to lose the potential revenue, as well as while at the same time stocking excessive products could also lead to loss. So they need to balance between these two. So this prediction of the sale will help them. So the objective here is going to be, in this problem you are tasked with building a machine learning model to predict the sale of products across stores for 1 month. Okay, so these models can be used to power the recommendations of the inventory management software as these stores. So so about the data set, we have sales, which is continuous, that's going to be our target, and we have different set of files. So that's the problem here. So every project will be facing some problems, so we need to overcome, and with help of pandas, how we are overcoming, that's what this is about. So you have a train.csv file, okay, sorry, train data.csv file, and you have some features inside of it, and you have product identifier, department identifier, categories, outlet, state and sales. Apart from that, you have something known as product prices in different one, and you have date to week ID map, that's a different CSV file. So you have 3 different CSV file, and you want to match all these things so that you could work on it together. So that's the first step. So combining this together is one of the bigger part here. So let us do it and start with the project. So let me move it hands-on. So I have loaded all these 3 different files. We have train data, we have product underscore CSV, and we have date to week ID map. So let us start with importing our required libraries. Let us import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, and import cbon as sns. So let us import all these things, and so let us go and explore. We don't know, right? We don't know what all these 3 different files have. So let me go with df training data. This is going to be pd.read_csv. So let me just load our train_data.csv. So where I have took this data, it is told that some NA values could also be in this format of question mark. So we need to include that also as null places. Okay, and also product underscore prices is also a data set we have. So let me just load that too with product underscore prices.csv comma NA underscore values, the same format you could include everywhere. Fine. And then finally date to week, okay, id underscore map equal to pd.read_csv we need to get this file, and no, we could directly copy the path or name of it, no issues, and then we could also do the same. Okay, so now we have loaded our data set, so it's time for us to explore it first so that we could understand how we are going to merge it. Okay, so first we'll go with df underscore train dot head. So let me go with that. So in df underscore train we have date, okay, we have product identifier, we have department identifier, some IDs, and we have category of products, so whether it's FMCG or others, maybe we have some other types too, we'll explore it later. We have what is the outlet, and we have the state, and we have sales. Okay, so this is what we have here, and let us go and explore the remaining things which we have. We'll go with product underscore prices dot head. Okay, so particularly in this part we have our target, which is going to be selling price. Okay, so we have some variables here, and it seems like we need to match these things. We have the same outlet here, product identifier here, the week ID is here, but week ID we don't have anything here. The common things we have is outlet and product identifier. So how are we going to combine these? Anyway, without coming into conclusion, I just want to explore this date to week ID map, which I hope is going to solve our problem. So let me explore that part too. So let us go with dot head here. So we have here the respective date and week ID. So this is what the data set we have. So here we can map the respective date and week ID. So if you map those two here, you could get all the features where you could join this with based on the date feature. If you combine, you can get the entire things joined in a single data set. So what I'm going to do is let us create something known as df, and you could use pd.merge from pandas, and I want to pass product underscore prices comma date to week ID map. Okay, in these two, how am I going to merge this? On is the thing, so I want to merge them both on week underscore ID, because that's a common thing I have. Okay, from this week ID just combine, which means both of these things will be combined with date. So the date can be added here based on matching. Okay, so wherever it matches, the date will be available. So here you have to pass one more feature which is very mandatory, which is called as how. There are something like inner, outer, and so on. So I'll go with how equal to inner. Okay, which means that based on week ID, this should be combined to this part. Okay, so in this data set this will be added, so that later on when you want to combine, you have to go with the next one. So let me run this, and if you go with the df, you will be getting something like this. Okay, so the date is matched with the week ID, and you have all your data now combined. Is this enough? No. So I want to combine this two here. So how am I going to combine here is I could combine with date and product identifier. And also I hope we could also give a feature which is called as outlet. So these three things we have, right? So we could match these in both the sites and combine it into a final data frame. So I'll go with train underscore data, a variable. I'll once again call pd.merge. Okay, so I'm going to pass my original one, which is df train, which I have loaded earlier, and this we have generated now as df. So on how you are going to combine, I'm going to combine with date, okay, and then product underscore identifier, and also I need to utilize outlet. So whenever it is matches, okay, combine that, and how is equal to, particularly it is inner. Okay, so let us do it and try to explore it, and which means that in train data now we will be having the combined features, which I don't also want duplicates. That's what the help of inner does. Okay, only one step will be provided, the remaining will be removed. So now we have our entire data frame with selling price too. So we'll explore once again. Sale is the number of product, and the selling value or the price or regression you are going to predict is sell underscore price. So we have our final data. So if you want, you could also see here it is 3,95,000, nearly 4 lakh rows and 9 columns is available. So let it be in this variable. So in data, I'll just take a copy of it, train underscore data dot copy. Okay, so new copy in the memory, so that now what all changes we do, we'll do it in data. Okay, and let it be as a sample, so that if required, in case we can go and use it later on. So for now we'll go into exploratory data analysis with data dot head once again. Okay, so we have these things. So let me go with data dot shape. Okay, and data dot info. And one thing for sure is, see here, this has a date feature. So if you want, you could take this as a time series analysis too. If you can find some seasonality trend, it may be new for you now, but after a few sessions you will be having some sessions on time series analysis. So if you have any date features, that can be also took as a time series project, but here I'm not going to utilize the date. I'll be dropping it and I'll be taking the remaining features to predict the selling price as a regression project. Okay, so this I'm considering it as a regression project. And if you remember, our task is to predict for every month. Okay, maybe for the next month you are going to predict for month twice. So what you could do is, from this date particularly, you could create a new column which is called as month, so that it stores what month it is actually, which will be really helpful for us. See here, these are all the data types we have. So what I'm going to do is, in data, let me create a month column. Okay, so the month will be equal to, so you could call pd.to underscore date time, because here the date is actually an object, it's not a date time feature. So I'll go with to date time. So let me convert it first into a date time data type. Okay, and in that I'll call dt dot month, so which will give me the month alone. So now that will be inside my data. Okay, so month feature will be there, a column will be created, data dot head. Okay, so we have the respective month, which month it belongs to, whether it's a January or February or March till December. And let us do some basic pre-processing, which means that since we got the month, now I don't need this date. So I'll go with also I don't need my week ID, is not going to be any of use here. So let us drop it with data.drop. So let us go with dropping few of the columns like date, comma, week underscore ID, axis equal to 1, in place equal to true. Yeah, so data dot head. Fine, so the final data set we have is here. So this is what we have finally. So let us go and explore. Our selling price is the target. So now I hope we will be having something like 8 columns. Fine. So let us go with data.isNull.sum in null values, since it's a huge data set, maybe or may not be. Fine. No null values, since we have at the earlier itself we have given the null values and it is not anywhere predicted. Fine. So I think I could go and continue with data.describe. We'll do the basic exploratory analysis and then we'll move into the remaining processes. Okay. So we have product identifier, department identifier, outlet, sale value, selling price, and respective month. Okay, so the sale actually minimum value start from 0.05 and then it goes to 2.68 in 25th percentile, and the maximum is 44.3. And the month, as we know, it starts January to December. Everything good, looks good. Okay, so we'll go with a few more exploratory data analysis. For example, before going into that, let me go with data.dtypes, and we could leverage some of the process here. So some of the continuous values are in the object feature, right? So I could take the objects alone, okay, using data.dtypes, wherever it is equal to object. So now it is going to provide me booleans, so I could directly use it as a filter and go once again with data.dtypes. Okay, so this is going to give me wherever it is object alone. So this is here, it's, you could take the 2 columns anyway, but if you have a length of columns, you could use these as a simple one, use a for loop. If you go with index, you will be getting the column names. So for x in or for c in this particular thing, so what I'll do is print what the x is, okay, and then sorry, what the c is here, c, right, and print data of c. So what I'm going to do is, let us get the value counts of everything, okay, and this will be really huge. You can't see here we have fast moving consumer goods, 2,22,000, 29,000, and 100, and we have drinks and foods, and we have others also, and state wise Maharashtra, Telangana, and Kerala. So the same thing what you could also do is, if you want to view it nicely, you could go inside of this and you could call. Okay, so instead of this we'll go with plt dot figure, plt dot title. Okay, so I'll pass C here, and sns dot count plot. So in count plot, if you pass the data as data and x equal to C, and plt dot show will do this wonderfully. Okay, so I think we could ignore this, and these are for the categorical features. So we could see that the category of product, we have others, fast moving consumer goods, and drinks and food, and the state wise. Okay, so apart from that, if you go and explore data.head, you have your month feature, right? So you could go with the month is also a categorical one here, but it is not, it is an integer data type. So sns dot count plot, data equal to data, and x equal to month. We'll explore that. So this is the month. We have January and February, the majority in the count, and the rest of things are nearly equal, around 30,000 each, contributing towards the entire thing. Okay, so yeah, so now we'll go and explore some of the continuous one too. For example, let us go and explore our target, which is selling price. First we'll explore the sales. sns dot hist plot. Okay, data of sell price. Let us do it. Keep the bins by default one. Okay, so this is what we have obtained. We could see some range of details. Anyway, so we'll go and explore the sales also. You could mention the bins if you want. Again, bins equal to, for example, 10, 20 can be splitted. Okay, with bins equal to 10, we could see that we have obtained, there is not much categories here. Most of them are ranging between 0 to this. Anyway, we'll explore first data of sales with unique or value counts will do it for us. Okay, so it is a continuous value anyway, so it ranges from 0 to some larger values. So data of sales dot describe. Okay, so we have a mean of 1.22, standard deviation of 3.5, and a max value of 293. So it seems like there are some huge outliers in this anyway. So let us go and explore this part also for C in data.d types. Okay, so where data.d types not equal to object, like we have done the object alone, and we'll get their respective index. And what I'm going to do is I'll go with plt.figure and sns.kde plot now. So let us explore its distribution, data equal to data, and the x equal to C here, and plt.show. So let us view it. Okay, we have product identifiers, department identifiers, categorical ones, outlet, just the data type. So we have the selling price here. So this is what the selling price distribution is. Our target. So obviously you are not supposed to scale or anything or touch your target. Okay, don't, if it is very deviated, if you find it abnormal, you could delete that. Apart from that, you don't want to scale or normalize or anything on your target. That is what suggested in regression. This is month, so these are all some of the continuous and categorical features. So now I'll move into exploring about the correlation. Okay, data.corr, and we have some categorical ones too. We will be having only the numerical one for now. So let us go with sns.heatmap. Okay, so data.corr, format equal to 0.1 float, and annotation as true, and with a color map of blues. So that's what I prefer. I'll go with blues. So this is what we have obtained with selling price. If you could see, there is no relation, no correlation found with the month, and a slight negative correlation can be seen with the sale, and no relation once again found with outlet, or a slight relation is found. Maybe if you go with 0.2f, could find some values here. If it's 0, it will be obviously 0.0, since it's a negative, some negative slight correlation, and slight negative correlation with department identifier and product identifier. We don't see any that much extent of impact on selling price. So we have left few things, because the categorical ones are still there, like the state and the category of product maybe could have some impact. Okay, so for that, what I'm going to do is, let us go with importing our important one from sklearn dot preprocessing, import label encoder. Okay, so let us go and encode it with encoder equal to label encoder. So yeah, so I think we can go, we need to do these two, right? So I think we can take it from here. So we have already wrote the code for it. Just copy it, do it in C, replace it in C, just a categorical ones. Okay, so I can go with data of C is equal to encoder dot fit underscore transform. Okay, so data of X, sorry, C, it will be transformed and replaced. So now if you go with data dot head, and if you want, you could go with a value count, so that the respective categories, whichever it is, you could found. Okay, so now what we could do is, let us go with SNS. Okay, I think we could use the same, since the data has changed. We could directly apply this. Now it will be giving the correlation table with new features. Some improvements, we could see the category has some positive correlation of 0.3, maybe FMCG you have good sale value and so on. And apart from that, state, it's once again has a slight negative correlation. So yeah, we need to leverage with what we have. So before winding up this exploratory data analysis, let me just go with a scatter plot. Let us create a function for it. Let us get the data set and column. Okay, and yeah, so we could go with plt.figure. We may use it for continuous features, right? So plt.scatter. So in data set of the particular column you are getting, comma, data set with respect to sales. I'm going to plot it for our sales, because we need to find the relation. We could explore it, right? With labels, yeah, it's optional. We could go with sales and plt.x label. So that is going to be the column. Okay, so in scatter, I could call the data, and let us pass for wherever it is not equal to object. I could get that, and I could pass that for our continuous values. So for all these things, just call scatter, pass the data, and column is going to be C. Let us try to get one by one results. Okay, get scatter, maybe with plt.show is required. Fine, it is not working with the loop. Let's try it outside. Data comma outlet. Okay, so this is what the output is. We have outlet versus sales. You could see some outliers here. So like that, you could call the scatter for the data which you want to compare. So let us go with state and find any relations there. Okay, this is for the state, and data comma category of product. Okay, so this is what their relation, the sale value and the respective thing. So this can be applied for all the continuous values, you could call it. And yeah, so I think we can jump into the next part of scaling these values for the next process. So since we have dealt with the encoded values, that is fine. So now we could move towards scaling. So from sklearn dot pre-processing, let us import standard scaler. Okay, and then what I'm going to do is we'll create object for it, scaler equal to standard scaler, and let us create it. And before moving further, so we have our data, so let us go with head. And you don't want to scale your target, right? Anyway, so in such cases what I could simply do is data 2 is going to be data dot drop. So let me drop the cell underscore price because I don't want it here. So access equal to 1, and I don't want to use in place because it is required. So y, I'll be taking my selling price, sell underscore price. Okay, so this is now available in data 2 because I'm going to directly call data 3 equal to scalar dot fit underscore transform. So I could pass my entire data 2 here, and if you go and check your data 3 now, it will be a numpy arrays because it's output from scalar. So if you want to turn it into a frame, data frame, you could go with let us do it in x equal to data 3 dot this pandas dot data frame. So you could directly pass data 3 here, and columns equal to data 2 dot column. So that's what I need to combine. So if you just do it in x, you will be having the scaled values, which is our features, and in y you have your target. So as we know, before moving into any other complicated step, it is better to go step by step. So what I'm going to do is I have my x now, so I have my y now. So what I'm going to do is from sklearn dot model underscore selection, let me import train test split. Okay, so let me go with x train, x test, y train, and y test is equal to train test split. Okay, let me pass x, y, test underscore size equal to 0.2, and random state equal to 42. So let me run this. Yeah, so now we have all these things. So as we know that we could go and create a model and try to explore how it performs. So let me start from sklearn dot linear underscore model. Let us import kickstart with linear regression models. Linear regression is a good model to kickstart with. And also for evaluation, let me go with sklearn.metrics. So in the previous project, it's a classification project. So obviously you will be using some metrics like accuracy score, confusion matrix, and classification report, and so on. But those things are not implied here. This is a regression project, so the metrics differs. Here you could go with mean squared error, root mean squared error, mean absolute error, and so on. So we only have mean squared error. If you want, you could take a square root of this value output, so that will be root mean squared error. So let me create an object for my linear regression, and let me just pass LR to fit the data of x train and y train values, x train and y train, and I'm going to use LR prediction will be equal to use this LR to predict it. Okay, so let me call dot predict. We can pass x test values, right? X test. Fine. So the LR underscore score will be equal to we could call numpy to square root this. I'm going to take root of mean squared error. So let me go for mean squared error. Okay, and let me pass. We need to pass the original one and the predicted one, which is LR underscore prediction. Okay, so if you just run this, you will be getting a score which is LR underscore score. and we got around 3.5. So it is completely different from classification problem, because in classification our main aim is to how much it is matching, how much the correct answer and wrong answer. So that's a different case, which means that there you will be having it within 0 to 1, the accuracy score and the prediction differs, but here it's a different scenario. We have learned about linear regression model, how it works and all. So we know that if you have a point, if you try to fit it in a straight line, how much the line passes through every point, the error will be less, which means if the line which is drawn to fit it, if it points exactly through all the points, then the error will be zero, which is practically not possible. So how much it is closer to zero will be considered as one of the good fit, right? So that's what our main objective is. We need to create it in a way so that if you want to compare models, how much it is closer to zero. For example, this gives us 3.5. If you use some other algorithm and if it gave you something like 2.5, something like that, so you have to prefer that model because that is the best model in the comparative way. So, and anything which is closer to zero will be best one, and anything between range of 0 to 5 is obviously considered it is performing well. Sometimes if you got around 20, 30 or something like that above that, or tells that your model is not performing well. So I think I could imply this with some other algorithm, like we could use XGBoost regressor. From XGBoost I'll import XGB regressor, and XGB is going to be XGB regressor, and let me call XGB dot fit. Train your X train and Y train values, and XGB underscore prediction is equal to XGB dot predict. We could pass our X test values for testing, right? So XGB answer is going to be np dot square root of mean squared error of particularly Y test and XGB prediction results. So let us print the XGB answer also. Sorry, it is XGB score or answer anyway. Okay, so what we could see here is this is actually performing well. Okay, so the predicted values here, we are comparing it in answer. Yeah, everything is fine. This is giving me 0.33, which tells that this is actually performing very well compared with linear regression. So this is a good sign. So obviously you have done it with your all the features, right? So for now XGBoost have performed really well. So now it's time for us to go and pick some other like select the important features and come back here. So let us see whether it is altering in any way or not. So feature selection, I'll import select kbest and mutual info classifier, sorry, regression, because it's a regression problem. So kbest is equal to select kbest, and I'll pass mutual info regression. Come on, the number of values, I'll pick the 4 important features. Okay, and we'll go with kb dot fit your X train and Y train values. And obviously the data is high, so it is going to check for some time, so the timing is a constraint here. Anyway, once I got this, what I'll be doing is I'll be usually going with X train 2. Now new features is going to be from X train. In that dot columns, do I need to take all the columns? No, I want to specifically get the support, kb dot get underscore support, and that will give me the selected features for training in train 2. And also since here it is completed, so I'll go and take for test. So X test 2 is going to be selecting the test columns and get the support. Okay, so now what we could do is we could also explore this X train 2 dot head. Let us see what all features do we have. So we have picked product identifier, department identifier, category of product, and the sale count. Okay, so as we've seen in the correlation table, that's what this guy is picking, right? So some unnecessary things which don't even have correlation or neglected. Anyway, so if you go and pick 5, you may get some more good input. So let me just explore this. I wish to pass the same thing towards this once again. So using linear regression, I'm going to go with LR underscore score, and instead of x train 2 I'm going to pass 2 x train x plus 2. Let us fit it and get the score 3.5609. Okay, earlier we got, okay, 224 in the end. Okay, some precisions has been changed, but it seems like it is not impacting our linear regression model that much. Okay, fine. So let us try to fit it with our XGBoost also. See whether it is remaining same or anything else. So if they are giving similar results, I will suggest you to go with the similar features, which, yeah, this is giving me 0.306 and here 0.33. Okay, so earlier it was best. Maybe we need to fit it around 5 or 6 important features which has slight relation to improve it. So it obviously your XGBoost is performing well, but you can't conclude it here, right? So you need to move further with something like let us go with creating a XGB regressor. Let us do a hyperparameter optimization. Why not? And yeah, so we can do, but one thing you need to also understand is it is furthermore closer towards 0. Usually your model will be around 1 or something like that, but this gives me some good results, and you could take it as a good and bad way. And the reason behind is, if you take it as a good way, it is performing well for this data. What if I give a new set of data? So over like this is also called as overfitting, where the model trains too much on the data, and it may result in some, like if you give your new data, it may struggle. Sometimes it is not applicable. So if we have a new set of data, we could also explore its property, so that whether it's a overfitted one or the fitting is proper or not. Anyway, so let us go. If you want, you could also implement a hyperparameter optimization. So let me type the code for it, and yeah, I think I can go with xdb equal to xdb regressor, and we'll create a parameter distribution. So I'll give it as like for example learning underscore rate. So the learning rate will be, could use something like a range to get it in a equal range of 0.01 till 0.2 with a gap of 0.01. So in that way it will be incremented, and you could have your n underscore estimators. So I'll set it into, once again, a range, so between 100 to 500 with a gap of 50 values inside. So obviously this is going to take a lot of time to complete, so we'll go with max depth. I'll go with np.a range from 3 to 10, and you could also add subsamples. And this I'll write the code and it will be in the downloadables. This is an assignment for you for the internship users. So what I'll suggest you is train the model and train this randomized search CV also, and try to find whether it is improving your process or it is not helping at all. Try to decrease it furthermore. Below that 0.33 is the benchmark we have obtained, but still closer towards 0 will be good. And it's one of the huge data set, which means that it's one of the positive signs which we have obtained. A range, I'll pass details like 0.8 to 1.0 with a gap of 0.05. Okay, so this is what the entire parameter distribution is, and we need a randomized search CV to complete this, right? So I could go from model selection. So let me just go with, yeah, I could do it here from sklearn.model underscore selection. Let us import randomized search CV. Okay, so this randomized search CV I will be implementing here. So I'm not going to run it. I'll be taking the SDBs which I used earlier. So random search equal to, you could call your randomized search CV. Okay, so you could pass the estimator as who is going to be your estimator. It is XDB regressor. So what is the parameter distribution is going to be? Your params, right? So apart from that, we need some properties like distributions, and apart from that, we need to mention what's the scoring you want to take care of. Here I'll go with negative mean squared error. Okay, so and also we need to pass some more details. Error comma cross validation, I'll go with 5, You can do an iteration of 10, and I'll set a random state. So these are all the features for it to run. So once this is completed, okay, you could get what you could do is you could go and fit it. Let me run this params. Okay, I also have it in param underscore dist. Yeah, that will be fine. So now it's ready. So if you want to run this, you have to call random search dot fit. Okay, if you pass your train values, it is going to be trained for a lot of time. This is a lot of features to pick some exact fit which performs really well. Okay, so after doing that, if you are training, you could call this random search. You could create a model by xcp equal to random underscore search dot best underscore estimator underscore. Okay, so that will give you the best model. So from that you could fit and predict your futures. Anyway, now I already have a XGBoost which I have run. Okay, I think I have declared it once again here, which means let me just go and redo this training part. Okay, this is 3.69, which I don't want. Obviously I want this feature which is 0.33. So let us fit and get, and yeah, 0.331, it's in XGB, right? So yeah, finally once you've done all the process, if you have a best model, what you could do is you could simply go and create a predictive system like we done in classification problem, predicting the sales for that particular month. Getting the input from the user, I'll create a list, and for a in xtrain dot columns. Okay, so what all columns you need, just ask me in this temporary variable integer input. Okay, so let me pass a formatted string of enter this particular a, and inputs dot append temporary one. So once I got all these things, so this input should be converted into array. So let me turn them into array as inputs, and the inputs is equal to inputs dot reshape. I'll do it in 1 comma minus 1, one row and all the columns, and the result is going to be given by xgb.predict. Okay, the trained model, I'll use it and pass this inputs. So let us run this. Okay, so what is the product identifier? Let me give a 0 1 category of product. I'll give it as 0. What's the outlet type? I'll give outlet type. Enter the state 0. Enter sale, I'll give it as 10 or 1, most commonly it is found. Enter which month, I'll give it as January. Okay, so the features have went into result. So if you just go and call the result, you could get your output. Okay, so 5.85. okay, so if you go and take that particular value, so that is going to be your result. So predicted sale for this month is the output. So you could use a formatting statement and make it look good. So this is what the predicted sale price value which has been obtained. So we have successfully created multiple models for this particular task which we have given. Like for a month, with month feature, if you use other features also to make predictions, you could proceed in this way. Also this product, if you explore, you could also do it with time series forecasting too. Anyway, so we have successfully built a model for this. So in the next session, we'll be having a project on clustering, which is unsupervised learning, and after that we'll move towards deep learning, then basics of time series analysis and combination of deep learning and time series analysis. Then we will be moving towards natural language processing and combination of natural language processing with deep learning. So deep learning will play further part, and after completing all these things with the objective towards data science, they will be helping their part in a lot of projects. So we'll have a few data science projects as well. So we'll see in the further sessions.